Here we have a neutral conductor, the metal sphere, on an insulating stand. A neutral conductor has no excess charge, but rather equal quantities of positive and negative charge. To make things easier to visualize in this part of the demonstration, only any excess charge will be shown. You will see one way in which a neutral conductor can acquire a net charge. In this case, it will be a net negative charge, but a net positive charge is also possible by using a slightly different method. If we bring in a rod with excess negative charge, the negative charges on the metal sphere will be repelled to the opposite side of the sphere, leaving behind an equal amount of positive charge on the side of the sphere closest to the rod. Note that only the negative charges can move. For every negative charge that moves to the lower left, a positive charge in the upper right remains. When the rod makes contact with the conducting sphere, some of the excess charge migrates onto the sphere. As the rod is removed from the sphere, the excess negative charge becomes evenly spread out across the surface of the sphere. This method of placing a net charge on the sphere is called charging by contact. An important thing to note is that the excess charge on the sphere has the same negative sign as the excess charge on the rod. Once again, we have a neutral conductor on an insulating stand. You will now see another way in which a neutral conductor can acquire a net charge. If we bring in a rod with excess negative charge, some of the negative charges on the sphere are pushed to the opposite side of the sphere, like charges repel, leaving behind an equal amount of positive charge on the side of the sphere closest to the rod. While at this point the sphere is still neutral overall, there has been a separation of charges due to the presence of the negatively charged rod and the fact that the negative charges on the sphere are free to move around the sphere. The positive charges remain fixed, however. If we connect the right side of the sphere to ground via a conducting wire, some of the negative charges will move off the sphere. This happens because the negative charges on the right side of the sphere are repelled by the negative charges on the rod. When the grounding wire and then the rod are removed, the excess positive charge becomes evenly spread out across the surface of the sphere. This happens because the negative charges move around the sphere and can only neutralize some of the positive charges, but not all. It's important to remove the grounding wire before the rod is removed. A significant thing to note is that now the excess charge on the sphere is the opposite of what was on the rod.